Hello and welcome to another video. In this video we're going to be working on maximum average subtree. And in the problem, given a root of a binary tree, you want to return the maximum average value of a subtree. And a subtree is any node plus all of its descendants. So in this first example, the maximum subtree is going to be here with a total of 6 and a average of 1, or an average of 6. So that's going to be the best one, because if you do something like this would give you a total of 12. And 3 nodes, this would give you an average 4, so that'd be worse. In the second example, we have a 0 with a null node with a 1, so the biggest average is over here. So the way to do this is going to be, let's actually make a tree here. Just make a tree like this with some nodes, and let's give it some values. So just say like 3, 5, 7, 9, 10, 2, 1, something like this, right? And now essentially what we need to do is we need to figure it out. So usually what I like to do personally is for all these binary tree problems, you're looking for an O of n solution, and usually with a DFS. It's like usually the easiest way by far to do this. So I ask myself, like, okay, can I do this with a DFS? And if I can't, then I'll try to look for something more complicated. So let's actually put it over here. So the idea is for an average, we need a total and a number of nodes. And the way you're going to want to do this is because we're going to want to maintain a running average, right? We're going to want to like calculate an average, then add some values and calculate an average, do that a bunch. So instead of storing an average, what we want to actually store is a total and a num nodes. And this is very easy to modify because we can just add to the total and add a node or however many nodes we need to the total. And we can always use this to calculate an average in O of 1. So what it's going to look like here is we're going to have a result. We're going to set it equal to 0. And now basically what we need to do is we need to figure out how do we do this with DFS. So what we can do is we can just have a function that traverses like a normal DFS traverse. So let's say we are here. So then we also need to figure out, like, when we traverse the DFS, do we want to traverse pre-order, post-order, and so on? And because for a node, in order to get the average with the other nodes, we want to get the other nodes first. We're going to do a post-order. Typically, for most DFS problems, you usually do post-order to get things because you usually want to get like a left value and then a right value and then do something with that whole tree. So with a post-order, we are going to start here. We're going to go left. Then we're going to go left. Then here, there are no nodes in here. So we just need to figure out like what's the average here. So the average here for a node with no children is just going to be 3, right? 3 in one node. So we will update our average over here to 3. And what we want to be returning is this, right? The total and the number of nodes. So how many nodes are there? There's 1 and a total of 3. So when we recurse here, we will return 3 and 1 node. Then for the 5, we're going to get the average as well, which is 5. And we want to return the same thing. We want to return the total and the number of nodes. So we'll return 5 and 1 node. Then for 10, what's going to be the average? So it's going to be the value. I can write this down. It's going to be value plus left total, right? So L total plus R total over total nodes. So what's that going to be? The value is 10. The left total is 3. The right value is 5. So we have 18. And how many nodes do we have? So we have the left nodes, the right nodes, and the node itself. So it's going to be 3. So the average here will be 6, which is bigger than what we had before. Then what are we going to want to return? We're going to return the total. So the total here was 18. And the number of nodes is 3, right? It's just the left nodes plus the right nodes plus the current node we have. Same thing for the total. Left total plus right total plus the current value we have. Then we go here, recurse left again. So we get a 7 and 1 node, and we don't need to, actually, no, this is better, right? So, yeah. So this is better. So we're going to put that in. And we want to return, same thing, total and number of nodes. So 7 and 1. Then we're going to go here, and this is an average of 9, so this is better. And then we're going to want to return the total and the number of nodes, right? So 9 and 1. Now for this, what's the average? So it's going to be 7 plus 9, which is 16, plus the 2, which is 18, divided by 3 nodes, which is 6. So this is worse. So we don't want to update our result, but we want to return all these things, right? So we're going to have a total of 7 plus 9 plus 2, 18, and a total of 3 nodes, 1, 1, and 1. Then we're going to check here what's the total. So the total is the left, which is 18, the right, which is 18, and the node itself. So we have 37. How many nodes are there? There's 3 on the left, 3 on the right, and 1, so 7. And so this is like 5 and something, right? 5 and 2 sevenths, which is obviously smaller than this. So our result is 9. You can also return like a best result so far, but the easiest way to do that is just define that outside of the function and then just maximize it for every single node. That's going to be the easiest way to do that. And so yeah, that's going to be everything we need. So now we can code it up. So what we need here is we need a result, and then we need a traverse function. So we'll say def traverse. It's going to take in a node. And if the node doesn't exist, then what should we be returning? Like, what's the total number of nodes? So if the node doesn't exist, we can just return 0 and 0, right? 0 nodes and a total of 0. Then we need to actually have this non-local result that we need to access. And what we need to do is we need to actually traverse left and right now. So when we traverse, we're going to get a total and a node. So we'll say like left total and L left nodes equals traverse node.left. Same thing for the right. Right total, right nodes equals traverse node.right. Then we need to actually calculate our current total, right? So current total is just left total plus right total plus node.val. And also for our current nodes is going to be left nodes plus right nodes plus 1. Right, that's how many nodes we have. Then we just maximize the result. So we'll say result is maximum of the current val over the current nodes. So current val, current nodes, and the old result. And finally, we need to return these things, right? So remember, we're returning a total and a nodes, and we're just going to be calculating our average on the fly. So we'll return current val and current nodes. And yeah, this is how you do a DFS solution. And this is what I would be looking for most binary tree problems. This is the easiest in my opinion. So, and if you can't do it, then try to do something else. So we just traverse and return result. Let's see what the error is. Oh, current val should be current total and current total. Let's try that. Oh. Okay, so our issue is we had a comma here, and current node is saying it's a tuple, so we need to get rid of that. So let's see. There we go. Okay. There we go. Pretty efficient. Yeah. So for the time here, it's going to be O of n because we're doing a depth first search traversal, and this is ideally what you want in your binary trees. You want to make sure that you have O of n traversal ideally. So go with depth first search. If you can't, then use like breadth first search or something. So pretty much almost all of these are going to be O of n. And then for the space, it's going to be O of n as well, because just like a normal binary tree DFS, your tree can be non-balanced. So if all your nodes are like a right child, then you would just have a recursive call stack of the length of the tree. So that's where you get the O of n space. Yeah, and that's going to be all for this one. So hopefully you liked it. If you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.